Hello, I'm Robert, volunteer fact checker, and helping you if you're scared of many things. And so for people who are scared of very large asteroid impacts. And we get these stories from time to time, and they're nonsense. We know all the asteroids that are as big as this tiny speck here that you can hardly see at the same size as the moon. That's 10 kilometers across. It's only 2 pixels on this image. And we know all the asteroids that size and larger that fly past close to Earth. And none of them can hit us for thousands of years. Then if you look at the moon, you can see there are craters on the moon. And these craters we know are very old, the larger craters, because lots and lots of smaller craters inside them. And by counting the small craters, we can tell that the big craters are very old. And the largest crater on the South Pole, the Aitken Basin, you can't see very well here. The Aitken Basin, it was hit by an asteroid this size. This is Ceres is the largest asteroid in the asteroid belt. This is the size of the asteroid that made the Aitken crater. And we have not been hit by anything that big that was 3.8 billion years ago by crater counts. And there's a similar sized crater called the basin, the Ceres basin on Mercury and the Hellas basin on Mars. They're all from that same time period, 3.8 billion years ago. We know why too. The planets and the moon were made from smaller objects that got built up to larger and larger objects. And the Earth and moon were from a collision of an object the size of Venus called Gaia, another object the size of Mars, and then the collision produced debris which formed the moon. And all that happened in the very early solar system. It got built up from smaller objects, just tens, 100 meters across, to larger and larger and larger. And then eventually, after the moon and Earth formed, there were still some of these objects lying around in the solar system, and the planets like Earth, they cleared up the debris from the solar system. And gradually it all got cleaned up, and that ended about 3.8 billion years ago for the larger ones. And that's why there are none left since then. And the Ceres and the larger asteroids like Vesta, they were left over because they were in the asteroid belt, which was a gap between Jupiter and Mars, where Jupiter's gravity stopped a large planet from forming, and so just these smaller objects there, and they were in circular orbits, and they can't be they're in stable circular orbits, so they can't harm us in any way. So there's not these big asteroids. It's just impossible. Like the asteroid the size of Texas is just impossible, because we know everything that big. And indeed, it's possible if you have very good eyesight on a very dark night, then sometimes you can see Ceres or even Vesta. And but it would just be one of the faintest of all the faintest stars in the sky, or a myriad of stars, and you wouldn't be able to tell it apart from any of the other stars. So the ancient people would have seen these asteroids but not known that they were asteroids. We only discovered they were asteroids in the 19th century, and then they found that previous astronomers had noted them down as stars, not realizing that they were actually asteroids. But if there had been an asteroid the size of the moon, then it would be far more obvious, and the ancient people would have noticed it as a faint star that they saw that was in different places and moved around relative to the other stars. So an asteroid the size of the moon would be very obvious. And we also have evidence from our spacecraft when they go out, especially Cassini, which went out to Saturn, and it let us monitor its position very exactly because of the radio time it takes for signals to go there and back again. And we know that if we look at all the material inside of Saturn, and they added up all the things we already know about and took away their gravitational effects, and what was left, the residual, was something far smaller than the size of Ceres. So that's the total of all the matter we don't know about. is far smaller than Ceres, inside of Saturn's orbit, which is way beyond Jupiter, which is way beyond Mars. So we know all the big objects right out to Saturn. And so there's also impossible for even an object coming from further away. Then you do get the comets, but they are very rare. So the closest that any long-period comet has got is Lexell's comet, which flew past 6 times the distance of the Moon. That's so far away that if you were able to travel in our fastest jet, the 737 non-stop, it would take 100 days to travel that distance, just travelling non-stop round and round the world, to travel the same distance as the distance to Lexell's comet. We have times 1.3 million years from now, we will have more comets than usual, but right now comets are extremely rare, the long period comets. And then we know the ones that the objects that fly past Earth regularly, and the 4 large asteroids, 4 large comets at 10 kilometers, and they can't hit us for thousands of years, so we're very safe. And that's not surprising, because we have never been hit by an asteroid even of 1 kilometer in diameter for 700,000 years. It's likely hundreds of thousands of years to the next one at that size. And we know nearly all the asteroids at 1 kilometer, and there's over 900 of them. There's only one left, 1950 DA, and this the one asteroid left in our risk list, it's got a slight possibility it's expected to miss in 2880, more than 4 centuries from now, expected to miss. On the very remote chance that it needs to be deflected, then we've got lots of time to deflect it. Remember, it's most likely hundreds of thousands of years to the next one at that size, and it's exceedingly unlikely that we find an asteroid of 1 kilometer or larger amongst the few dozen left to find that has even a remote chance, even centuries in the future. And 1 kilometer in diameter is below that, it can't have any effects globally. At 1 kilometer, its effect is similar to a large Pinatubo volcanic eruption in the late 20th century, which cooled the Earth down slightly, and most people didn't notice it unless you were a geek and followed the science news. And so below 1 kilometer, they don't even do that. And so there is a very slight risk from smaller asteroids. And these people who go looking for asteroids with their mobile phones and looking for planets with their mobile phones, they don't have a clue. If you think about solar eclipse, then before the eclipse starts, you don't see the moon. The moon is there in the sky, just as big as the sun in the sky. But because we see that the dark side is pointing towards us at the time of the solar eclipse, when it's near to the sun in the sky, we don't see it until it goes in front of the sun. Because we've got the blue sky, which is very bright, in front of the dark patch, which is what we'd see if we were in space looking towards the moon. We just see a dark patch with no stars. So the idea of pointing your mobile phone at the sun is absolutely ludicrous and doesn't make sense. You're not going to spot an asteroid or planet that way. We sometimes see Jupiter in the sky because it's the largest, and sometimes Venus as well, in the sky close to the sun, but you'd have to block out the sun's glare because it's very bright, and then you'll see a very, very faint white speck against the blue of the sky, and you only see a difference in colour. It's the same brightness, it's not brighter than the sky. It's the same colour as the brightness of the blue sky, but it's white instead of blue. A little bit of cloud, and you've obviously got no chance of seeing it because it's the same colour as the cloud. And just imagine like a cloud, which is a tiny, tiny, tiny speck, just almost just a single pixel or a single point of white that you can see, and so you can't see that with the naked eye on a very clear blue sky if you block out the sun and you know what to look out for. And that is what a planet looks like when it's near to the sun in the sky, and that's the largest planet in the solar system. and Venus as well, when it's which is the closest planet that's nearly the size of Earth, and it's quite close to us sometimes. But when it's the far side of the Sun, or quite a bit away from the Sun, you can't see Venus when it's close to the Sun in the sky on this side, because just like the Moon, you only see it when it crosses the Sun. So in the same way, an asteroid that is coming from the direction of the Sun, we won't see it in the sky, because if you can't see the Moon, you can't see an asteroid, even a small one, even a big one. But that doesn't mean that we are at significant risk from asteroids, because we can see them at any other time. So our big telescopes are out there looking for asteroids every night, and as soon as the Sun sets, and right through to just before the Sun rises, and so that means they can see very close to the Sun, because once the Sun sets, they can then look at the sky just above the Sun, and when it rises, they can see it again just above the Sun. So they can see nearly all the night sky, except a little sliver near to the Sun. And so in that, then they can see asteroids against the darkness of the night sky. So we can see asteroids, but if the asteroid happens to be in an orbit that takes it really quite close to the Sun before it gets to Earth, as seen in our sky, as seen from us as it's approaching Earth, it's very close to the Sun in the sky, then we can miss it still. We can only miss small asteroids like that, because the larger ones, we will see them further away from, when they're quite far away from the Sun in the sky. And the Earth goes around the Sun every year, so we see the Sun from the other side, 6 months from now. So it's impossible for an asteroid to hide from us behind the Sun for any length of time. Or if it is, there are some asteroids that are almost the same orbit as Earth. They stay the other side of the Sun, but then if they're in an orbit like that, then a very slightly different orbit, they'll gradually creep out from behind the Sun, and then we'll see them as soon as they appear, and they'll take a long time to get to Earth. So the only risk is from very small asteroids coming from the direction of the Sun, and we can miss those. And so that's how we missed the Chelyabinsk asteroid that hit Russia. And we would see most asteroids at that size before they hit. We can miss the Chelyabinsk, but your individual risk from an asteroid like that is absolutely minute. Last century, 3 reindeer herders died in Siberia. Some people in a small hamlet in Mexico died. And if you look at the entire history of the United States, nobody has ever died of an asteroid. It's very rare. Meanwhile, 20 people die of lightning every year in the United States, and very occasionally someone will die in the United States of a large hailstorm. This is a very rare form of death, that if you see hailstorms that are hitting cars and actually denting the cars, then you don't go out into that kind of a hailstorm, because that's the kind of hailstorm that can kill you if you're unlucky. It seems kind of obvious if you stop and reflect, but sometimes people, when they're panicking or when they're worried about their car or something, they mightn't stop and think that something's going to dent a car, it's going to be harmful to humans. So that's you sometimes get people get killed, or people who just can't get to shelter in time in that situation. But it's very rare. It only happens every few years in the United States. Well, the death from an asteroid is you're far less risk of dying of an asteroid than you are of dying from that very rare death from a giant hailstone. So it's really not something to be scared of. And then probably we'll eliminate it completely as we continue towards the second half of this century, because we have such complete surveys of even the smaller asteroids. And if you get this small, you never need to worry about a shooting star or a fireball, unless it's a very, very, very big fireball like the Chelyabinsk one, because sometimes little bits from those will fall to Earth, but because they're really quite small, they're not going to hurt you even if they hit you. Because small things, if you drop small things from a great height, they just kind of flutter down, and they're like the mouse dropped off the Empire State Building. And So there has been one injury from meteorite so it is possible to be injured by a somewhat larger meteorite. So there's one lady in the United States got injured by a meteorite that bruised her thigh. It was a very serious bruise. She had to be treated in hospital. So that's one accident that's come from a meteorite in the entire history of the United States. So I can't tell you that it's impossible to be harmed by an asteroid, but it's exceedingly rare, and it's not something to be scared of. And then as time goes on, we'll know these things so well but at the moment, most of the asteroids, if they come close to Earth, and if they hit Earth, then we're going to predict them before they hit, and then they'll tell people to evacuate in that very remote possibility. And then, just to say, the governments do not hide news of asteroids. It's impossible. The people who search for asteroids, then they are, that's their life work. They keen on asteroids, they went to university probably, they studied for a doctorate, they wrote a doctorate about asteroids, they're researching and looking for asteroids every day of their life. If they find an asteroid, they'll be shouting to the world that they found an asteroid. They're not going to be hiding it, and they can't, because of the way it's set up, that they submit their coordinates to the minor planet center. And for them to hide an asteroid, it's just impossible. It's like a weather forecaster trying to hide a hurricane, because anybody else can just go and look and see, even if one weather forecaster was to go completely crazy and go on and say, we're going to have a lovely sunny day tomorrow, and all the other weather forecasts saying, no, there's a hurricane. Because just like lots of weather forecasters, lots of asteroid searchers, including lots of amateurs too. So there's absolutely no possibility of some kind of secret knowledge of an asteroid that nobody knows about, because everybody would see it. With all the asteroid searchers and all the big survey telescopes and so on. Anyway, I talk about all this and some other matters in my longer video. I'm trying to keep this video short, to focus on the things that scare people. So hopefully this will help you if you're scared. I know I'm going to upload a much longer video which goes in lots of other things that might intrigue some of you. Did I explain about comets? Oh, just quickly about comets. The closest any comet has come is Lexell's comet, which at 6 times distance of the moon. Did I say that? And it would take it would take 100 days traveling at 737. I can't remember if I said that bit. We don't need to worry about comets either. Anyway, that's in a longer video if I haven't said it in this one. It's they're exceedingly rare. And anyway, I'll upload this video.